Okay, we are moving on to our second factoring lesson. Okay, I'm showing you this flow chart again. So I want to remind you the first rule of factoring is to always look for the greatest common factor, GCF. It's your number one rule of factoring. You always need to look for it. If it has one, we'll take it out. If it doesn't, then we'll look to see if the problem has 2 terms, 3 terms, or 4 terms. So far, I have taught you how to do something with 4 terms, and I've taught you how to do a GCF. I haven't taught you how to do 2 terms or 3 terms. So that's what we're visiting today. All right, so here we go. First thing up. Just looking at example 1, I look to see if there's a GCF, but nothing can go into 1 and 81 besides a 1, and they don't both have x's. Okay, so this does not have a GCF. So do you see how every problem on this page has 2 terms? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, so taking you back to the chart. When something has 2 terms, we look to see if it's a thing called a difference of squares. So I need to explain a difference of squares for a little while. This explains what it is, but it may not make sense to you, and this shows you an example of how to do it. Okay, so I have several things I need to explain before we actually do these problems. So first thing you have to know is what the word difference means. Difference means you're going to have a subtraction sign. If you don't have a subtraction sign, there's no way it could be something called a difference of squares, because difference means subtract. Now, the square part means you need a perfect square on the left side of the minus, and you need a perfect square on the right side. So now you may be wondering, well, what are perfect squares? So we're going to make a list of, not all of them because I can't list them all, but I can list several of them. So perfect squares, let's start with numbers. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. 12 times 12, 144. 13 times 13, 169. 14 times 14, 196. 15 times 15, 225, etc. Now, I could keep going, 16 times 16, 17 times 17, but there's no way I could ever stop with that game. So I'm just going to stop here. Now, the reason these are perfect squares is because when you take the square root of them, you get pretty little whole numbers. The square root of 1, a pretty little whole number. The square root of 4, a pretty little whole number. The square root of 9, a pretty little whole number. The square root of 169, a pretty little whole number. So these are perfect squares because when you take the square root of them, you get pretty little whole numbers. But if I try to take the square root of something not on the list, like 8, 8's not on the list, I don't get a pretty little whole number. So 8 is not a perfect square. Okay, now you see that in these examples below, we have variables too. So we need to know about variables. As far as variables are concerned, you need even exponents. Doesn't matter what the letter is, but the exponent has to be even. So exponents, I'm just going to write EXP for exponents, are even. So if there is a variable, it has to have an even exponent. 2, 4, 6, 8, 10, 12, 14. Hopefully you all know what even exponents are. Okay, now if you find that a problem is a difference of squares, it's always going to factor with 2 sets of parentheses, one with a plus, one with a minus. It's always going to be that way. Okay, so let me just show you. So example 1. I already know it doesn't have a GCF. Let's see if it's a difference of squares. It has a minus sign, so it is a difference. Now I need to see if this is a perfect square and if this is a perfect square. Does your variable have an even exponent? Yep. Is 81 one of our perfect squares we talked about? Yep. Okay, so as long as it's a difference of squares, it's two sets of parentheses. One gets a plus, one gets a minus. Okay, so to figure out what goes in the parentheses, you take the square roots of these guys. So the square root of x squared is x, because x times x is x squared. And the square root of 81 is 9, because 9 times 9 is 81. And that's your answer. Now, I always have a few students every year that ask, how can this make this up here? So I'm going to show you how to check your work. I'm not saying you have to check your work, but this is how you could check it if you wanted to. So I could multiply these out, which means FOIL or double distribute. So first I'm going to distribute the x. So x times x is x squared. X times negative 9 is negative 9x. Now I'm going to distribute the positive 9. So positive 9 times x and positive 9 times negative 9. So positive 9 times x is a positive 9x. And positive 9 times negative 9 is a negative 81. Well, then you can combine like terms. Well, what do you get if you combine a negative 9x and a positive 9x? You get 0. They're just out of there. All you're left with is the x squared in the front and the minus 81 in the back. And do you see? That's how our problem started. So that's why this is the answer. When you multiply it out, it gives you what you started with, so you know you're right. So this is a way of checking your work. Not saying you have to do it, but it's a way to check your work. So if this did not multiply out to give me this, then I've done something wrong. So for example, if I had made these both pluses, then this would have been a plus, and then those would have made 18x, but I didn't have an 18x. If I would have made a mistake and made those both minuses, then that would have been a minus, and these would have made negative 18x, but I didn't have a negative 18x. That's why in order for you to only have two terms, these middle terms always have to zero out. And the only way they'll make 0 is if one's a plus and one's a minus. So that's why one has to be a plus and one has to be a minus. Okay, let's keep trying. So first, you're always supposed to look for a GCF. And that's because it's the number one rule of factoring. But there's nothing that can divide into 36 and 1 besides 1. And they don't both have D's. Okay, so then I check to see if it's a difference of squares. It's got a minus, so it's a difference. Are these both perfect squares? Yeah. 36 is in the list. 1 is in the list. And my exponent is even. Okay, so I'm going to build my two sets of parentheses. 1 is always a plus, and 1 is always a minus. And then I take the square roots. So the square root of 36d squared is 6d, because 6d times 6d is 36d squared. And the square root of 1 is 1, because 1 times 1 is 1. And that's my answer. I could check it if I wanted to, but I know it's right, so I'm not going to. You may not know it's right, so you might need to. All right, next one. First, I look for a GCF. Now, there is nothing that can divide into 25 and also divide into 16, because the only thing that goes into 25 is a 1, a 5, and a 25, and 5 and 25 can't go into 16. Okay, and they don't both have W's, and they don't both have Z's. So let's see, since it's two terms, 1, 2, if it's a difference of squares. It's got a minus, so it's a difference. Are these both perfect squares surrounding it? Yes. 25 is in my perfect square list, 16 is in my perfect square list, and the exponents are even. Okay, so I get to lay down two sets of parentheses. One has a plus, one has a minus. Now let's take the square roots. The square root of 25w to the fourth is 5w squared. And that's because 5 times 5 makes 25, and w squared times w squared makes w to the fourth. And then the square root of 16z squared is 4z, because 4z times 4z is 16z squared. And that's my answer. Okay, let's jump to number 5. Looking at number 5. First, I look to see if there's a GCF, but nothing can divide into 4 and 121. They don't both have x's. They don't both have y's. Okay, so since it's two terms, 1, 2, let's see if it's a difference of squares. It's got a minus sign. Okay, so it's a difference. Are these both perfect squares? They are. So let's build our two sets of parentheses. One's going to get a plus. One's going to get a minus. And then I'm going to take my square roots. The square root of 4x squared is 2x, because 2x times 2x is 4x squared. What's the square root of 121y squared? 11y, because 11y times 11y makes 121y squared. These are pretty easy, don't you think? I think the difference of square problems are the easiest that there happens to be. Now, at this point, hopefully the example on the flow chart makes sense to you. Okay, now number 6 is different. What's the first thing that we're always supposed to be looking for, by the way? A GCF. Every time we're supposed to look for it. It's the number 1 rule of factoring. Now, we haven't had one today, but this time we do. What's the greatest number that can divide into 3 and also divide into 48? Always try the smallest guy, remember? And 3 can go into 48. Okay, so there's a GCF of a 3. Now, do they both have a K? Nope. All right, so remember from our GCF lesson, whenever there's a GCF, you always build one set of parentheses behind it, and then you figure out what goes in the parentheses, so you get both of these back. So what could you multiply 3 with to get 3k squared? A k squared. Now, what could you multiply 3 with to get a negative 48? A negative 16. Okay, so today is the first day I'm going to show you a problem like this, but it's something we need to be on the lookout for. If there's a GCF, sometimes you can factor what's in the parentheses. So I'm going to cover up the GCF and pretend what's in here is the original problem. Okay, so I'd go back through my flow chart and I'd look for a GCF again, but there's no GCF to those. Then I count my terms, 1, 2. And whenever there's 2 terms, I want to see if it's a thing called a difference of squares. Is that a difference of squares? It sure is. It's got the minus sign, and those are both perfect squares. Okay, so I'm going to build my 2 sets of parentheses. One is getting a plus, and one is getting a minus, and then take the square roots. What's the square root of k squared? K, because k times k is k squared. And then what's the square root of 16? 4, because 4 times 4 is 16. And then this GCF that we took out at the very beginning, we need to drop it down. So, shoo, drop your 3. And that's your answer. So this one had a GCF and a difference of squares. So we're going to start looking for more than one thing if we have a GCF. Okay, let's just go to number 9, and then I'm going to teach you something else. Okay, number 9. First thing on the list is to look for a GCF. Now, if some of you straight away thought this was a difference of squares, it's not, because this is not an even exponent, nor is that. So it's not a difference of squares. So let's look. Do we have a GCF? We do. What do they both have? They both have a C. Okay, so every time there's a GCF, build one set of parentheses, and let's get these 2 terms back. So how many more C's do you need? 2. And then what could you multiply C with to get a negative 100C? A negative 100. Okay, now let's cover up the GCF and look at what's in parentheses. So I'd look for a GCF again, but there's not one. And then there's 2 terms, 1, 2. So I want to see if this is a difference of squares. Is this a difference of squares? It is. So I'm going to build my 2 sets of parentheses. One's going to get a plus, and one's going to get a minus. And then I take the square roots. What's the square root of C squared? C, because c times c is c squared. And then what's the square root of 100? 10, because 10 times 10 is 100. And then this GCF that we took out at the very beginning, don't forget to drop it. Shoo! Now, before we move on, I want to show you something that hasn't come up yet. So let's backtrack to number 8. I'm going to change this problem. So let's pretend that this was a plus instead of a minus. Okay, so I did just change this to a plus. All right, so first I would look to see if we have a GCF. Can anything divide into 25 and divide into 81? No, and they don't both have a's. So then I'd count my terms. 1, 2. So when there's 2 terms, I want to see if it's this thing called a difference of squares. Now remember, difference means minus. Is this a difference of squares? No, this is not a minus. So it doesn't have a GCF. It's not a difference of squares, so you can't factor this. And when you can't factor something, it's called prime. Okay, moving on. Now, this is the one that tends to be hard for people. This is when we have 3 terms. So let me show you the flow chart. 3 terms. 1, 2, 3. And we rooftop. And I like to call it A times C rooftop. So let me explain that. A is the number in front of the x squared, B is the number in front of the x, and C is the constant. So I like to call this A times C rooftop. So the first thing you do is you take your A times your C and see how that looks like a rooftop. So that's one reason why it's called rooftop. So I take my A times my C, and that's how I begin the problem. Okay, I do have one problem already worked out for you, but like I said in another video, sometimes it's confusing to explain a worked out problem already until you know what you're doing. So once you kind of have an idea of what you're doing, then you could come back and look at this as an example maybe. Okay, so here we go. So don't forget, the first thing you're always supposed to look for is a GCF. So let's look. Can anything divide into 6, 23, and 7? No. And they don't all have x's. So then you count the terms. 1, 2, 3. So as soon as you see that there's 3 terms, we're going to A times C rooftop. Okay, here I go. I'm going to take A times C. And I don't do anything with the letters right now. So my A is a 6, my C is a 7. So I take 6 times 7, and I make this x. And 6 times 7 is 42, and I put that up here. And then I want B to be down here. So B is the number in front of the x, so B is going to go down here. All right, so it's like a little puzzle. You're trying to figure out 2 numbers that multiply to make 42 and that add to make 23. So I need 2 numbers that are going to multiply to make 42, and those same 2 numbers add to make 23. Now, some students can get these numbers in a flash, and other students sit there for 10 minutes. Okay, so one thing I'm going to do is I'm going to show you one way to not sit here for hours. Whatever you're trying to get them to multiply to be, start making a list. 1, 2, 3, 4, 5, 6, etc. And eventually you're going to find 2 numbers that multiply to make this and add to make this. Okay, so I start with 1, and I ask myself, 1 times what makes 42? Well, 1 times 42 makes 42. Then you ask yourself, okay, well, do these 2 numbers add to make 23? Nope. So I move on to the 2. 2 times what is 42? 21. Then I ask myself, do these 2 numbers add to make 23? Yes, they do. Bing, 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 bing. Now, sometimes you don't find your numbers that fast, but sometimes you do. Okay, so this is how this is going to work. Now, I like to nickname this next step drop, replace, drop. Dr. D. Drop, replace, drop. So I drop the 6x squared, I replace the 23x with these two numbers that we found. So this is a positive 2, so I put plus 2. But if the middle letter has an x, this has to have an x. And this is a positive 21, so I write plus 21. But if the middle letter has an x, this has to have an x. So I dropped, I just replaced, and now I'm going to drop again. Now mathematically, the reason I can do this is because 2x plus 21x makes 23x. So since those make the same thing as that, that's why mathematically you can do that. Now, this goes back to the first lesson I taught you. When you have 4 terms, 1, 2, 3, 4, you factor by grouping. So you group together your front 2 terms and you take their GCF out. Do you know what the GCF is to those front 2 terms? 2x. Always build your parentheses after you find a GCF and get these two things back. 2x times what is 6x squared? 3x. 2x times what is 2x? A 1. Then you're going to group together the back 2 and take their GCF out. But this is when I taught you how to cheat. Remember, whatever you write in this set of parentheses, you get to write in this set of parentheses. Always just copy it over. Now you can come back and figure out the GCF. What times 3x would make 21x? A positive 7. So 7 times 3x is 21x, and 7 times 1 is 7. Okay? So then I build my 2 sets of parentheses. Remember, whatever you wrote here and here, you write one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, goes in the other set of parentheses. Now, if I wanted to check my work, I would distribute this out. 3x times 2x, 6x squared. 3x times 7, that's 21x. 1 times 2x, that's 2x. Well, 21x plus 2x makes 23x, and 1 times 7 is 7. So it works. So when you distribute this times this, this times this, this times this, this times this, it should make this when you're done. If it doesn't, you've done something wrong. So you can always check whether you're right or wrong when you do these factoring problems. You remember doing this in your past? This can be scary for students sometimes. Okay, let's try some more. Now this one wasn't too bad because this was a positive number and so was this. Once you start throwing some negatives in, that's when students struggle a little bit more. Okay, so now remember, I am always supposed to look for a GCF first, but there's nothing that can divide into 4, 5, and 6 besides 1. And they don't all have x's. Okay, so as soon as you spot that it's 3 terms, 1, 2, 3, you A times C rooftop. Now, when you do it this time, A is 4, but C is negative 6. So 4 times negative 6 is negative 24. And then the B, the number in the middle, goes down here. So you're looking for 2 numbers that multiply to make this and add to make this. And some of you probably already know them, but some of you probably do not. So we're going to do what I practiced a minute ago. Whatever you want them to multiply to be, let's write that down. And let's start making a list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, however many it takes until you find it. So 1 times what is a negative 24? A negative 24. Now, do these two numbers add to make negative 5? No. Now, to multiply to make a negative 24, it is possible that maybe the 1 is the negative and the 24 is the positive. So you don't know which one's going to be the negative. So you have to check them both. But will these two numbers add to make negative 5? No. Move on. 2 times what is negative 24? A negative 12. Do these two numbers add to make negative 5? Nope. What if you switch it and make the 2 the negative and the 12 the positive? Do they now add to make negative 5? Nope. Move on to 3. 3 times what is negative 24? Negative 8. Do these two numbers add to make negative 5? Yes, they do. Bing, 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 bing. A 3 and a negative 8. Now, if somebody put the -8 here and the 3 here, that's fine. It doesn't matter. Okay, so now we're going to do our Dr. D. Drop, replace, drop. Okay, so I drop the 4x squared. I replace the -5x with these two numbers. So plus 3, but give it the x that the middle guy had. Minus 8, but give it the x that the middle guy had. And drop the -6. So if the middle letter was a y, these would both be y's. If the middle letter was x to the 4th, these would both be x to the 4th. Okay, once you have 4 terms, 1, 2, 3, 4, we do our factor by grouping. So you group together your front 2 terms and take their GCF out. Now, do you know what the GCF is to that? Just an x. The only thing they both have is an x. Okay, so that's your GCF. Okay, now let's get both of these terms back. X times what is 4x squared? 4x. X times what is 3x? 3. Okay, now I'm going to group together the back 2 and take out their GCF. But I'm going to cheat. Whatever I wrote here, I copy here. Can't look different. Don't make it look different. Now backtrack. What times 4x would make a -8x? A -2. And -2 times 3 makes -6. Okay, so it works. Okay, so I'm going to build my 2 sets of parentheses. Can you tell me what goes in one of them? 4x plus 3. And in the other set, x minus 2. It's whatever is left over, the guy in the front and the guy in the middle. So x minus 2. And that's your answer, which you could always multiply out and make sure that it gives you what you started with. But it does. Okay, what'd you think of that? Okay, let's go over to number 5, only because there's positive and negatives. Okay, so this one, there's no GCF that can go into 8, 10, and 3. They don't all have x's. There's 3 terms, 1, 2, 3, so we're going to A times C rooftop. So 8 times -3 makes a -24, and we want the numbers to add to make -10. Okay, so you're looking for 2 numbers that multiply to make this and add to make this. If you don't know them, take what you're trying to get them to multiply to be and start making a list. 1, 2, 3, 4, 5, 6, 7, etc. Okay, you're going to find it. This at least gives people a place to start other than just sitting there trying to think of it. So 1 times -24 makes -24. Do these add to make -10? No. What if you switched the signs and made the 1 the negative and the 24 the positive? Nope. Okay, 2 times what is -24? -12. Do these 2 numbers add to make -10? Bing, 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 bing. Yes, they do. A +2 and a -12. Okay, so now I'm going to drop, replace, drop. So drop the 8x squared. Replace the -10x with these guys. So that's a +2. Don't forget his x. That's a -12. Don't forget his x. And drop the -3. Okay, then I've got 4 terms. 1, 2, 3, 4. So I'm going to factor by grouping. If I group together my front 2 terms, can you tell me what the GCF is? 2x. Okay, build your parentheses, and let's get both of those back. 2x times what is 8x squared? 4x. 2x times what is 2x? A 1. Okay, now let's group together the back 2, and I get a copy. So whatever you write here, you copy here. Now what could you multiply with 4x to get a -12x? A -3. Now let's just make sure that -3 times 1 makes the -3 in the back. And it does. Okay, so we're ready for our final step. We build our 2 sets of parentheses. Whatever you wrote here and here, you write one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, goes here. So 2x minus 3. And that's our answer. And this is A times C rooftop. What do you think? Okay, let's try it again. So this time, our A is a 1. You just didn't see it there. So there's no GCF because nothing can go into it. This is a 1, too. There's nothing that can go into 1, -1, and 56 besides a 1. And they don't all have y's. So 1, 2, 3 terms, we A times C rooftop. What do you get if you take A times C? A -56. And you want the numbers to add to make -1. Okay, just to speed this lesson up a little bit, it is a -8 and a +7. -8 times 7 makes -56, and -8 plus 7 makes -1. But I could always make my little list like I was. Okay, so now I'm going to drop, replace, drop. I drop the y squared. I replace the -1y with these guys. So -8y plus 7y. Remember, you have to put the same variable behind them that the middle guy had. And drop the -56. Now that there's 4 terms, 1, 2, 3, 4, I factor by grouping. So if I group together my front 2 terms, what's their GCF? A y. That's what they both have. Okay, build your parentheses. Now let's get it back. Y times what is y squared? Y. Y times what is -8y? -8. Okay, and then the back 2. Okay, I'm going to cheat first. So wherever I wrote here, I write here. Now backtrack. What times y would make a 7y? A +7. And then make sure that 7 times -8 makes -56. And it does. Okay, so let's build our 2 sets of parentheses. Whatever you wrote here and here, you write one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, goes there. So y plus 7. Now, this problem is special, and I want to teach you how to do a shortcut with it. Now, if you don't want to do a shortcut, you don't have to. You can do it the long way because it clearly works. But I want to teach you a shortcut and teach you how to know whether you can do a shortcut or not. So one thing I want you to notice, do you see how the 2 numbers that we found are the same 2 numbers you see in the back? -8, -8, +7, +7. But look at these others. +2, I didn't have a +2 back here. -12, I didn't have a -12 back here. +3, I did have a +3 back there, so that was fine. But -8, this wasn't a -8. So this one, not special. This one, not special. But this one is special. That number is in the back. That number is in the back. So I want to teach you why it's special and how to look for it. It's all about the A. If your A value is a 1, then I like to call this one the easy one. And you're going to hear me say that numerous times the rest of the year, and it's going to be very annoying. I'm not going to lie. So as long as there's a 1 in front, I call it the easy one. And I can skip this and go straight to the answer. So I want to show you how to do it. Okay, so look at number 7. Looky, looky. It's got a 1 in front, so it's the easy one. So I'm going to start it as if it wasn't. I would take A times C. So 1 times 32 is 32. And I want the numbers to add to make -12. Okay, I'm looking for 2 numbers that multiply to make 32 and add to make -12. Now, this is the hard part for people. So when I call it the easy one, they're like, this isn't easy, because finding these numbers is not easy for people. But after you find the numbers, then it's easy. Okay, so let's just say you're struggling. let's write down what we want them to multiply to be and start making a list. We're going to find it eventually. 1 times 32 makes 32. But do these numbers add to make negative 12? No. Now let me ask you a question. Will two positive numbers ever add to make a negative? No. So that means these can't both be positive. So remember how a negative times a negative also multiplies to make a positive? Now I want to check if those add to make negative 12, but they don't. Okay, so 2 times 16 makes 32. But remember, two positives will never add to make a negative. So let's make them both negative. Do these two numbers add to make a negative 12? No. 3 can't go into 32, so go into 4. 4 times what is 32? 8. But 4 plus 8 doesn't make negative 12, so let's make them both negative, and now they work. So those are our numbers, negative 4, negative 8. Bing, 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 bing. Okay, so let me show you how to do the easy one. Once you get your numbers, build your two sets of parentheses. Whatever letter the problem's working with goes in the front, and whatever the two numbers you found go in the back. So minus 4 goes in the back, minus 8 goes in the back, and that's your answer because it's the easy one. Now, I always have a handful of students every year that they don't care if it's the easy one or not. They want to do it the long way with the drop, replace, drop. So if you want to drop, replace, drop, you can. But if you don't want to, you don't have to. But I do need to explain, if there's a 1 in front, that's the only time you can go straight to the answer. If there's not a 1 in front, you have to drop, replace, drop. There's no shortcut if it's not a 1 in front. Okay? You can only do the shortcut if it's a 1 in front. Okay, and that's all for this lesson. Smile.